All right, good afternoon. Hopefully you can hear me okay, and you have hopefully enough lunch and make sure you guys don't fall asleep. But the next 40 minutes, I would like to share with you a little bit around how security for mobile have evolved and the risks of AI, because I think everybody here is aware of what's coming and what's going on. But I want to give you guys a perspective on how attacks are also leveraging AI. So before I start, I just want you guys to know, if you never heard of Zimperium, there's two things that I want you guys to remember. The first is we work with the New York City Cyber Command. We publish a NYC secure mobile application that all the residents in New York can actually download and protect your mobile devices against phishing, malware, other security risk, right? So that just gives you a good idea that we have been around for 12 years and we continue to do our best to protect the cybersecurity landscape for mobile. So even if you don't live in New York, you can still download it. Now, the second thing I wanted to share with you just a little bit about Zimperium is we've been working with Google for the last, I think, 7 years. If you develop mobile application, if the application gets published into the Google Play Store, most likely our machine learning AI engine have already scanned your application. We provide, as part of the App Defense Alliance, feedbacks around how your application is doing, and let Google ultimately decide what security posture, whether they allowed or reject the application. So my name is Shueh. I've been with Zimperium for about 12 years. Like to share a little bit, at the moment I look after a product, but today is all about immersing you guys about how the attacks are changing and how you guys should be aware how to defend against that. So we actually publish every year a global mobile threat report. So as part of our solution, we provide protection over millions of devices today across the world. Some of those data, when the customers allowed us to collect it for global research purposes, we actually publish the report to just let everybody know what threats are actually we're seeing. And our solutions are sitting inside one of those, many of those big mobile applications that you use for banking, probably on your phone today. One of those media applications that you watch movie. And many other payment applications that you might have on your phone today, right? So even though you might be protected by our solution today, you might not be aware of. So I wanted to share a little bit about the inside of the threat report, which we publish every year, and then go through some of the attack scenario that we're observing. So before I get started, how many of you guys here regularly pen test your application? Can I just have show of hands? Okay. All right. Only two. So, okay. There's a few of you guys. Now, how about in terms of application scanning, right? How many of you guys do source code scanning? So you go through your pipeline and you scan your application. Okay. So some of you guys do that. What about binary scanning? What about you take the binary? Okay. So we got a few people who is quite mature, I think, in the processes. We'll talk a little bit about what binary scanning is, but essentially rather than looking at the source code, we are looking at the APK file, the IPA file. You might be wondering why. Because most of the code in your mobile is not written by you, it's by third party. And then we'll go into a little bit more information about that. Now, what about obfuscation? How many of you guys are using obfuscation to protect your app? Great. Well, that's better than last year for sure, because when I asked the question, I think most of the people are looking at me and say, "What? I use Google, I use RA. Is that obfuscation?" As a good starting point, but I'll tell you more. Now, what about runtime protection? Checking if the device is jailbroken and rooted. Okay, all right. So you guys are in the right place because clearly you are doing something, and maybe I can enlighten you more about why it's not enough. The last question I have is, what about protecting the cryptographic keys? So in your app, you have data that you encrypt and decrypt. Anything you encrypt from the server goes down to the device. You need to decrypt it. Where does the key stored and how do you secure that? Do you guys do something about that? Okay, all right, cool. Now, I'll go through some example of how the landscape have been changing. first thing first is part of the report, which you guys, I'll flag the report again. You can all download. The numbers are actually increasingly becoming quite interesting. 1 in 400 Android devices, and 1 in 2,000, about 2,500 iOS devices are compromised or jailbroken and rooted, right? So while that may be a big number or a small number depending on your perspective and depending on the type of application you're using, but the more interesting number is actually 3 out of 1,000 devices are compromised. Let me define compromise for you, because compromise basically means that your device no longer have your control. You believe that you're using your device to do things that you're doing, but someone else is actually have control of that, which means that anything that you do could be exposed. There was a joke a while back. People was telling me, Pat, I think most of the devices are compromised anyway. Google, Apple, everybody's is watching us anyway. So this is a little bit different. This allows the bad actor to do something. What's really interesting also is malware. The number of malware, 1 in 5 Android devices, we have seen malware. And 80% of those malware are actually installed not from the official store, but from a sideloading of an application through sophisticated campaign, social media, WhatsApp messengers, etc. What I wanted to focus on is across the globe in the financial sector, malware are now becoming the dominant force of conducting fraud. We're seeing a lot of the consumers losing funds, and they have no idea because there's this app that was installed on the device that ended up allowing the attacker to control the application. More to come later. Now, let's talk about vulnerability and CVEs, right? So if you remember the number previous slide, right? 60%, 49%. So about half of the devices that's running in the world today are vulnerable. They are running some sort of older operating system. They are allow the attacker to essentially take control. So CVE is a measurement of how much of those vulnerabilities are being discovered year on year, right? So this is the last 3-year data. If you're an investment kind of person, you can see Apple stock, just like the stock is going up, the vulnerability are also going up. With Android, you can see there's a big drop. I don't really know why. The numbers are all of a sudden reducing, but you can see probably in about 2 or 3 years, Apple is going to overtake Android in terms of the critical vulnerability that's been discovered. Now, let's see a little bit more. From security perspective, you guys probably don't know how much people are paying for this vulnerability, right? So if you look at Android and iOS, 0-click. So these news that you hear on the media that someone is able to send you an iMessage, maybe a WhatsApp message with some special payload, your application would process that malicious message, and then all of a sudden it's been taken over. These are the kind of market that attracting a lot of the attacker, and a lot of the AI is now being used in fuzzing the code, identifying vulnerability, and helping the bad guy to get there. So now, most recent example, I think 18.1 iOS, just by introducing a feature called nickname, the attacker is able to flood the nickname update to any of users' device. If I got your phone number today at the event, I'm able to execute malicious code and take over your phone. So the numbers are actually going to get worse, and this is an area of security research that's focusing on. So whether you're using iOS or Android, guys, I think we all vulnerable. Now the next thing that's also very important as a developer over here, you need to understand how are you securing your data. So how many of you guys use WhatsApp here? Yeah, you all have. Okay, half of you guys. WhatsApp has this end-to-end encryption, right? The messages are secure from the device that you left the device all the time, through the communication to the other device. On the right-hand side is the database that sits on the user's device. So if you have a jailbroken or compromised device, you can actually copy the SQLite database, and when you open that up, it's actually in clear text, right? So now you might think, okay, well, that's probably not a big problem. But the story here is if you build application, if application contains sensitive data, a lot of the developers today trust the operating system. Because I just put it in my application sandbox folder, I'll be fine. but it's not the case because people can actually extract that information. That's where data leakages and things are actually happening. Okay, if you want to see a real demo, we actually have devices and example we can show you, but this is live, even the latest version of WhatsApp. But it's actually not because of the application, it's because developer depending on the operating system, and that is the weakest link. So question for you guys is, if you have data in your app, how are you securing that data right now? Now, another thing that is very common, when I speak to developer, they say, oh, we use keychain. Keychain is secure. Secure to a point, right? If your device is compromised, remember it's no longer in your control, the information can also be dumped, extracted, and this is how a lot of the reverse engineering or attacker, they use their application or their phone. They compromise the phone and they analyze your data, your application, in order to figure out how to extract this at big scale. Okay, so this is another example for you to remember. Just because you are using some of the security control, it's again based on the assumption that the device is secure, but most of the time you don't know if it's secure. Now the other one is data in transit. So this is one of my favorite topics actually. A lot of the developer I talk to, they say, my app is secure. All the communication is SSL ping to the server. I don't have anything important on the device. Everything's in the back end. Now, SSL pinging, right? It's a painful thing to do, right? You guys need to make sure configuration is right, you have the right domain, but within 5 minutes, any decent attacker plus AI can SSL unping your application just by simply running a command. So again, 30% in our analysis, right? Application that we scan across millions of apps in the store, they're actually vulnerable to this particular attack. Now, let's continue. Remember I was talking about apps that you guys build, the SDK that you're using. A lot of the time it's pre-compiled, so you don't have the source code, so you don't really know what the SDK is doing to your application, to your data, right? And this is an analysis again across millions of apps on the public store. We are actually analyzing or running the application in a container, and we are tracking where the data are going, right? So if your app runs in our environment and is communicating to certain country by sending data, now we have a list of those countries. Not so interesting, but it's actually very important for your developers or security team to understand, hey, I have an app that's doing a QR code scanning or maybe doing some mapping. Why is the data going to this country? Today, it's very difficult, extremely difficult for you guys to find out, right? And do you guys feel this is important? At least knowing where things are going, right? And this is one of the blind spots. And source code scanning is not going to tell you that. Now, let's move on. Jailbreak and routing, that's another topic that I think I was speaking to one of the developer earlier. They say, oh yeah, we do root and jailbreak check. I said, that's great. How do you keep up? They said, what do you mean? So over here, and this is one of the blog we published recently, there's various different tooling out there, open source, in Android and iOS that helps the user to jailbreak or the attacker to jailbreak their devices. This is typically used by the pen tester today. And there are different variants. You probably heard of Magisk. It's one of the very popular tools for hiding the root or bypass any root detection. And now, if you look at the first column here, these toolings are being updated on a weekly basis. So the first one, A-Patch, every 2 days they release new updates. I'm sure you guys don't release updates to your application every 2 days, right? So continuously, these are something that will be, it's a challenge for developer to keep up, because your job is actually not coding and keeping up with security. It's about how do you focus on the business value and then improve these kind of risk. So also looking on the right hand side, these are open source projects. They have lots of contributors, probably more than the developers that you have in your team that focus on security as well, right? So again, something to be cognizant of. Now, during the report, we also analyze what sort of protection the apps are actually using, right? So if you look at the tooling here, about 60% plus, so about 80% of the mobile applications out there are using some sort of open source tooling or maybe no protection, right? Very rarely, about 20% of application, and it was actually quite interesting that finance, we would have thought it would be a lot higher. They're actually not using as much comprehensive protection. So if you heard of R8, I think there was a presentation earlier, how to secure and minimize and optimize your application. It does provide some security, but it doesn't really help you against the attacker, which we'll show you in a little bit. Any of you guys use root beer for root detection in your app? Okay, great. Root beer is a great platform. At least someone else is handling the security. You can use them. However, it's also very easy to be bypassed. Okay, so you probably heard about the play integrity and a lot of the approaches that the platform vendors are building as well. But ultimately, it's still signature based, meaning that tomorrow, one of these guys release a new version of their root hiding tool. Your application protection knowledge is not up to date, and you're not able to keep up. Now, if you we can look at this later. I have a quick demo to show you. Reverse engineering an Android application is actually as simple as drag and drop. You can see on the left-hand side here, the R8 does class and method name renaming, right? So it makes it very hard for you to understand what that method or function is doing. But if you actually open up that file, all the source code are still in clear text, right? So you slow down the attacker a little bit, but attacker can still look for stuff, API keys, tokens, server IP addresses, etc. So you're kind of done the half protection, but still a room for improvement. Now, this is the root beer example. So on the left-hand side, you can see I'm running one of the root hiding tool, right? So I can just select. Let's just make sure when root beer asks question to the operating system, is my device jailbroken or router is compromised? You just make sure you answer no, right? So you can see by running this hiding tool, root beer all of a sudden now don't see the device is compromised, right? And this is not it, because just like open source community have given to us, there's a lot of tooling that will help you hide your application, bypass Google Play integrity check, all sorts of interesting ideas that people have. And again, it's just a module people can install. Now, the last bit of data that I want to share is around malware, right? So I don't know how many of you guys actually care about malware. Can I just get a show of hand? Do you care about apps and malware today? Okay. All right, some of you guys. Okay. So how do you defend against malware protection today? Is it based on hashes, based on bundle ID, based on signatures? Because a lot of the time, when I speak to some of the developer, they say, well, we are developer now, we're being asked to write malware scanning engine inside our app to protect against the emerging attack. And that's not really something that the developers are trained for. So what we wanted to show you is, in fact, every 1 in 5 devices has malware, and 80% of these malware are 40% of these malware are spyware. So what does those spyware do? They actually have access to accessibility permission. You have ability to read the screen, key lock your screen, even the ability to run through transactions. We have seen attack in Asia where while the lady is sleeping, the attacker was able to unlock the phone, launches the banking application, logging to the application. Biometric was there, by the way, and he goes use password instead. He logs into the app, transfer a amount of $10,000 out of her bank account. She wakes up and the bank account is empty. This is all done through malware without the lady or the user have any knowledge until it happens. So this is really a new attack vector. I know in the US things are a bit slow. I recently moved from Singapore to US, so I'm still learning how some of the security policies are not enforced here, but it's actually very prevalent in other parts of the world. So now the last thing I wanted to share is this concept of virtualization. We hear about virtualization before, right? VMware, etc. Guess what? Malware is now leveraging virtualization. So let me introduce you to Godfather, not the movie, but the malware family. It's been around for 4 or 5 years. Now, the most recent malware targets across 500 banking applications globally. And what it does is it actually leverages multiple application payloads. So you might get a WhatsApp messages on some special discount on the meal. It could be some useful services that you use and consume. That application downloads it, and then it uses that application to install a malware. And that malware then takes over accessibility permission. It will run the application inside the first app. Meaning that anything that you do, right, within your real application, the banking application, now you are under the control of the malware, the parent malware, which means that any information you type in, any 2FA token you get, as well as all the security control you have, can all be bypassed. Because from the app perspective, everything looks normal. It's a normal user's app. You can read more about it on the link and on the blog post there. So that's one example. Now, the last example I wanted to share, this is fairly recent. So in certain parts of the world, they don't believe on SMS OTP. They don't believe on 2FA token. They now believe on video authentication, right? So this is where a lot of the banks are using video as a way to authenticate even onboarding of a new customer. So this is actually in Vietnam, where they were able to hire or buy accounts from a lot of the users and make them create new accounts. And when they create the account, the KYC process is to show a video of yourself. They do it with the pre-recorded video, which bypasses all the biometric authentication, and they use that for money laundering. Again, right? So I hope US or a lot of the countries are looking at all the different techniques people are using and how it's getting attacked. And now if you look at here, right, your application is never designed to detect or protect against these type of use cases. And one of the things that we wanted to share here today is while things are getting better, is your security defense is getting better, right? And this is where some of the ideas for you take away on best practices. So first thing first, you want to make sure you scan your binary, because source code scanning is not going to tell you where the data are going. The source code scanner is not going to tell you what this proprietary library is actually storing, sending data to, right? So by running this type of processes, you probably heard about Mobile SF. It's an open source toolkit that does similar things. We actually have a platform that runs against every application gets submitted. We can look for dynamically what your app is actually doing, where it's sending data to, and then integrating that into your existing CI/CD pipeline. So that's the first step, because you kind of want to, I use the analogy, you do health check, right? Pen test, health check, you do that once a year to make sure you're healthy, but tomorrow when you go out or under this heat, you get sick. So scanning and doing mobile application security or security in general doesn't help you against the attack. It does tell you there's a problem that you might come and bite you later. So that's the first step. The second step is runtime protection is no longer about root and jailbreak. If you look at the example that I have here, I know it's a very busy slide. The intention is not to put you to sleep, but root jailbreaking is really just the first step. Because now, what about devices running outdated operating system? Maybe SSL pinning, someone's trying to manipulate and bypass that. Do you have the ability to know that? Is there a malware on the device? Is the app installed from the genuine source versus a sideloaded through WhatsApp or other social media application? All the way down to the last point here, about if your device is now running in a farm where a lot of people are trying to exercise that remotely, are you aware of that this type of activity is happening? Right, so runtime protection now evolves closer to what the device is actually behaving, what the user is doing to the device. Are there sensors being touched on your on the application's device's screen? Because if it's not being exercised or touched, and your transaction, your application is running, then something is pretty suspicious, right? So we built an engine based on machine learning and AI around this type of activity, to give you the signal, because ultimately your job is to make sure when there's a risk escalate, you're able to take action against it. Okay, so with all this information and data that we collect, you now have a visibility around security. So you know how many devices are running with malware, maybe how many users' accounts are actually being attacked. And this is the type of thing that you do today, maybe with Sentry, with Google Firebase, analytics. You got a lot of performance data, but you don't really have a security data. And my number one question to most of the developers or even security team is, if you don't know how you're getting attacked, how are you going to ever protect against your application and users? So this is one of the things you wanted to consider. Now, I think I just want to finish off the presentation here. I do have a quick demo to show you as well. But ultimately, AI can help you write code. AI can help us look smart. AI can also make attack much easier. In fact, if you guys try to upload your APK file, IPA file to one of the LLM engine, and don't say you are trying to attack the app. Just say, what are some of the potential vulnerability in this application? You can feed it the MASVS guidelines. You can feed them some of the standard best practices. AI is going to tell you and find issues for you, right? And this is just the beginning. They can be very well trained to do the attack as well. Now, really understand what are the gaps in your application. So really assessing the risk before you take action, and really have the ability to build an application that monitors itself. Because ultimately, if you don't have those insights, and you have stats from firewall, from your desktop for antivirus and malware, you have all this information. Why? Because you want to protect against those assets, right? The application that you build is one of the biggest assets in today's world. And lastly is about education. So now, if I wanted to show you guys for the first time, you have not seen how easy it is to reverse mobile application. There's always a dilemma, right? Because I go to these events and people will say, hey, why don't you open up Uber? Why don't you open up, I think Amex was here earlier. And I say, hey, why don't I just give me the permission and I'll reverse engineer your app? And he said, no, I think it's not appropriate, right? So I decided, since there's a droidcon app, it's publicly available, so why don't we do that, right? So now, first thing first, there's several open source tools out there you can install, and this is just a little editor that you can run locally on your machine. And then what you can do also is for any APK files or binary AAB file, you can just simply drag and drop. So let me see if I can get my mouse to work, right? So now drag the APK in, just give it a second. Now it's actually decompiling the APK file. And within a few minutes you can see, let me see if I can make it bigger. You can see the source codes. So once I open up the source code tab, these are all the code, the Java or the Dex code that is compiled and now being decompiled. I can go into any of these file here, right? The droidcon app. I can open any of these classes because as a developer, these are the code that you actually write and gets compiled. So what took less than a minute. Now, what you can also do is you can look at all the assets, right? So assets are typically where your SSL pinning libraries and files are stored, maybe your API key. I can also search for things like all the communication that's in the application. Because this app doesn't actually do a lot, so there's not a lot of interesting stuff here. But this should give you an idea. If an attacker really was trying to focus on and learn about your app, they can do this offline without bothering you or anyone else, simply by just getting access to the binary. Okay? So from here, what they can do is they can now understand how you communicate to the API to the backend, because you're talking to the server, right? With certain API. So if I can take that API, then I can maybe use it. In fact, I actually have an app that I downloaded from a third party. Hope no one works for New York Times here. So there is a special version of New York Times app that is subscribed, meaning that the information that you normally have to pay is now being bypassed. How does the attacker do it? Same thing. Look at how these communications working. Maybe the guy personally go and pay $10 for the subscription. Now look at how the information gets updated. Now creates a patch. And now I'm able to patch an application, then distribute that to a third-party store, right? So this is one of the first thing that the attacker would do, right? So obfuscation using RA can help you slow this down. But now, if I really want to continue this particular attack, I'll run it on the device that's already rooted or jailbroken. And this is where I can actually get more information. So now I have a video to show you what that looks like. Because this is being recorded, so I have to be very careful on what I say. Remember, the attacker owns their application. So here is an example on the left. It's a WhatsApp application. By the way, let me just go back a little bit, right? So this is just an internal test application. This is a Pixel device running Android 13. It has a GPU vulnerability, right? So guys, GPUs, hardware vulnerability cannot be fixed by software. So the attacker was able to acquire this device, go to the version of the firmware, it's able to run the exploitation to gain full root access. So now, if I just show you here, now, so this is an example. The device is compromised already. Remember those security software that keeps telling you, if you're using Microsoft Outlook, I hope you guys use that for email, right? Maybe your company uses it. It prevents you against rooted and jailbroken device. This device is rooted. It protects against screenshot. This device, I was just able to take a screenshot. So the perception of that security based on the trust on the operating system is really what a lot of the security products are built on, right? So the takeaway here is none of these can be trusted. You really need to have awareness on what's going on. Let me just go here. I just wanted to finish off the presentation, the demo. I'm not trying to make our customer look bad, but here is a application. I'm writing some email. I'm doing key logging actually. So when the attacker controls your device, they can select which application to take, and then any things that you do on the device, the attacker is able to capture. Right. So that is a very, very quick example, not trying to make anyone look bad, but the vulnerability of the application if the device is in the total control of the attacker. Now I will stop here. If there's any question, please come by to the Zimperium booth. We are more than happy to give you some more detail. And also, if you want to keep safe, please download the NYC app and just make sure your device is good. And by the way, we're not monitoring you guys. Yeah. Okay, thank you very much for your time.